Okay, today we're going to work on Unit 1, Lesson 4, which is representing data. Here are your state standards. Again, pause it if you'd like to see what they are exactly. Crunching data. How do scientists make sense of data? Scientists often create a data table for recording and organizing their data. You've already done this with the Speed Lab. You made a data table to record and organize your information. Data are the facts, figures, and other evidence gathered through observations and experimentation. So in the Speed Lab, your data was a number. It was how many seconds it took you to do something. Information recorded in data tables include times, amounts, frequencies, number of times something happens, maybe a temperature. Units of measure should be recorded in column headings in a data table. A title must always be added to describe the data in the table. If you have no title, somebody would not understand what you were recording data about. Constructing a graph of data allows a scientist to recognize patterns. So when you take your data table, you make a graph out of it, you can right away see if there are any patterns or if there is a correlation between two pieces of observations that you're looking at. A bar graph is used to display and compare data in a number of separate categories. So a bar graph is for comparing things in different categories. Types of shoes students like to wear to school, for example. The length or height of each bar represents the number in the category. A line graph is a different type of graph, and it's often used to show continuous change over time. So you plot your points and you connect them with a line, and it shows how things change over time. A circle graph, or a pie chart you might know it as, is used when you are showing how each group of data relates to all the data. So the parts of a whole. So what part of 100%, for example, of students like pizza for lunch? What part of 100% of students like the lasagna for lunch, etc. What do graphs show? They are visual representations of data, and all graphs should have a title. Once again, if you don't have a title, no one knows what your graph is about. Graphs make it easier to understand data than just a data table by itself. Looking at the data table can be overwhelming, just seeing how many numbers, especially if you are doing a good experiment with lots of data in it. In some graphs, data on the horizontal axis are the values of the independent variable. Remember, those are the ones you change on purpose. So horizontal goes long ways back and forth. Independent variable, thing you change on purpose. The independent variable is the one that's manipulated or changed, like we just said. The data displayed on the vertical axis are the values of the dependent variable. So up and down the vertical axis, you know it as the y-axis, is the dependent variable, so what you're measuring. The dependent variable is the variable that changes as a result of the manipulation of one or more independent variables. So what you're measuring, the thing that you're looking to change, to see change. Making a bar graph requires several steps. First, you have to draw a horizontal axis and a vertical axis. So you've got your x and y axis, side to side and up and down. Write the names of the categories to be graphed along the horizontal axis. So remember, with the horizon back and forth, the x-axis. Label the vertical axis, the y-axis, with the name of the independent variable with the units. Create a scale along the axis by marking off equally spaced numbers that cover the range of the data collected. So if your data goes from 0 to 20, you have to mark off on the y-axis 0 to 20 in increments that are necessary for your data. So maybe it's by ones, maybe it's by halves, maybe it's by fives. For each category, you draw a solid bar using the scale on the vertical axis to determine the height, and we'll do one of these in class. Don't worry if this seems kind of abstract because you can't see it. All bars should be the same width, so you wouldn't want to make a bar 1 inch across and another bar ½ an inch across. You want to make them the same width. Add a title that describes your graph. What types of models can be used to represent data? A model is a representation of an object or a process that allows scientists to study something in greater detail. We learned this already. Models can represent things that are too small or too large to see fully, such as a molecule is too small, we have to make a model of it. The solar system is too large, so we have to make a model of it to represent what it is. A model can also represent the past, the present, and the future. Physical models are models that you can touch. So like a model of the solar system or a model of a molecule, those are physical models. You can touch them. Physical models often look like the things that they represent. Examples of physical models include toy cars, models of buildings, maps, globes, etc. A mathematical model is a different type of model that's made up of an equation or data. Mathematical models can be simple or they can be very complex, very detailed. A computer may be needed to process the models. So anytime you put something, like if you put something into Excel and you tell it to find the average, that could be considered a mathematical model in some ways because it can process that information. Model allows scientists to change variables without affecting or harming the subject they are studying. So you can use a model without affecting or hurting any subject you're studying. All models are limited because they are simplified versions of the systems that they are trying to explain. So when we talk about a limitation, that's like something it can't do. Well, it's a very simplified version. That's one thing that is a limit of a model. That's very important that you understand that. It's too simple. It could never be as complex or detailed as the real thing. It would be very difficult to get it there. All models can change as new data or concepts or ideas or technology is brought to the forefront or added. What are some benefits and limitations of the model below of Earth? So one, it's limited because it's not nearly as complex as what the inside of the Earth looks like. Yes, there's a mantle, a crust, and a core, but it's definitely not showing the tectonic plates. It's not showing much of the detail that exists on the Earth. One benefit is that it is something that many people can understand. It's very hard to explain that the crust is the outside layer, and then you have a mantle, and then inside you have this core. So it's a great representation of what it looks like. Okay, so now is the time where you need to fill out your visa and have that ready for class. When you come tomorrow, have it out and ready to show me. Get a parent signature, tell me how long it took you to do it, and fill in the illustrations, the questions, and the summary.